Well, hi. This is my first attempt at a video lecture for Module 1A, 1B. The specific topics that I am going to address are, as posted here, first one being square roots, followed by adding signed numbers, adding and subtracting fractions, and subtracting real numbers. So those are the topics that we're looking at um, today. So, square roots. To talk about square roots, you can find a little bit more about square roots on this page 481 in Toby. Um, going to give you a little bit of a definition. The square root of a number is a value that, when multiplied by itself, is equal to original number. And again, this is coming from the page 481. I really want to stress that. So flip over to that page and you would see that definition that I just gave you. So we're talking about a value that, when multiplied by itself, is equal to the original number. So here, for instance, take this, the square root of 25. What is the square root of 25? Well, by that definition, what we want to do is we want to find some number such that when we multiply that number by itself, we get this 25 right here. Okay? What number can we think of? Well, 5. So here, also in these videos, I want you to use this as a way to know how to show your work. So since 5 is that number, what we would have is, in place of that 25, we would just put 5 times 5. Okay. And another way of looking at that, we have a repeated multiplication of 5. This is 5 times itself twice, so that's the same thing as 5 to the second power. So that's just 5. So that's how a problem like this, square root of 25, what that would look like with all the work shown. And it's equal to 5 because why? Because 5 times 5 is equal to 25. All right? That's one square root problem. Example. Here's another example. So let's say if we had the square root of negative 36. So is there a number, a value, such that when we multiply this value by itself, we can get a negative 36? Okay. Well, we know that 6, when we multiply 6 by itself, we get 36. That's a positive 36. But the number that we're looking for is a negative 36. So that's 6 isn't going to do it. Another number you might be thinking of is a negative 6. So if we take negative 6 and we multiply negative 6 by itself, what do we get? Well, a negative times a negative will necessarily give you a positive. So that is going to be equal to 36. And again, that's not what we want here. What we want here is a negative 36. So both of these will not work. So what is the square root of negative 36? Well, that is something that we're not necessarily going to get into during our time together. It's an imaginary number. So what is the point? There is no real number that satisfies this criteria for square root. And the thing is, in general, if you're finding the square root of a negative number, it will always be the case that there is no real number that follows this criteria. point blank. Okay? So, continuing on with our talk about square roots, there's another problem that I have. An example, say. So this is going to be the square root of 25/81. And actually it's going to be the opposite of the square root of 25/81. So now how does that work? Well, it works like this. Going from left to right, what we want to do is to make this numerical expression a little bit simpler. This minus sign, there's no simpler than that, but since it's there, we have to represent this here. Now, the square root of a quotient, we could break up in the following way. The square root of that quotient will be the square root of the numerator divided by the square root of the denominator. So something looks like that. All right, so we've got the opposite of the square root of 25 divided by the square root of 81. Okay, if we go a little bit further, square root of 25, well, actually, we still have that minus sign. We can't forget that. But the square root of 25, well, we had a problem like that. That's 5. And then, what number can we multiply by itself in order to get an 81? And that number would be 9. 9 times 9 is equal to 81. And this is what we have, -5/9. And the last check for these is we want to see if we could reduce, that is, if there's a common factor between the numerator and the denominator we could divide out. There isn't any, so this is it. This is what the opposite of the square root of 25/81 is at the end of the day, -5/9. Okay? So, oh no, one more problem. Dealing with our square roots. One more example, say. So there's this. Let's say if we had the square root of 196 plus the square root of 64. What would that be? Okay. Square root of 196. Again, we're figuring out a way to make this simpler left to right, just one step at a time. We can find out what the square root of 196 is. 196 is a perfect square. In that, well, there does exist a number such that when we multiply that number by itself, we get this number that's under the radical, this 196. And what is that number? You might have to punch in the calculator. You might have to do some timetables. After you do a little searching, you'll find out that that's 14. This plus sign will have to repeat here, so that's plus. And the square root of 64, what is that? That'll be 8. So this complicated numerical expression we made a little bit simpler in that we figured out that easier way to say this is 14 plus 8. And we could figure out 14 plus 8 here. That would be 22. Okay. So that's dealing with a little bit about square roots. Again, it's in our Toby book on page 481. If you have any questions, be sure to ask. Find me sometime. Find one of our student ambassadors, tutoring lab, and such. Hope this helped.